In year 2044 in Belgium, there will be no bees. Terrifying, right? But how did this happen? The Asian hornet, originally from Asia, arrived in Europe hidden on a cargo ship. That ship docked in France in 2004, and from this moment, the invasion began. Its spread across Europe is rapid, and the impact on the bees is devastating. And what about the result? Disrupted ecosystem, threatened food security, and even billions of agricultural losses. Our project is very unique, and nobody had done anything like this. We worked with data from multiple sources, from academic research to our partner sources, and these data sets had never been connected before. It took us a lot of effort to put them together. We started by mapping Asian hornets' hives across Europe. Over 200,000 documented sightings have formed the basis for our prediction. Then we analyzed how the invasion was spreading, country by country. We also studied whether natural predators could stop the hornet, but the reduction was minimal, only 5.5%, which is simply just not enough to change this game. We modeled the impact on bees, and in some countries, the decline is dramatic. When we combined everything, bees, hornets, and predators, the full forecast revealed how serious the situation really is. This is how the future might actually look like. Now you are looking at our model's prediction of bee population in Europe up to the year 2050. The colors are very simple. Green means hope, red is severe risk, and black means total extinction. We identified 4 countries which are facing total collapse. First will be Belgium, then Spain, Portugal, and Netherlands. Overall, we are talking about loss of more than 36% of bee population, which means loss of over 4 billion euros in European economic annually.
Even though we included the predators of the Asian hornets in our analysis, we find out that these hornets are still faster and hungrier. Our results showed us that it stays alarming and these hornets are still spreading fastly and growing rapidly. That's why we think the only viable solution for this problem may rely on bioengineering, which means, for example, generating genetically modified bees that are more resilient, or even robotic bees that could take over the role of the bees pollinators totally. It sounds like a science fiction, right? But maybe that's how far we'll need to go. To make our findings accessible to everyone, we created an open source platform where you can find out more about our project in more details. It's really clear, simple, user-friendly, and easy to understand even for the non-experts. And looking ahead, we see several important next steps. We are already collaborating with some experts in this field, like the organization like the Gaia, BSage, and the European Beekeeper Association, who already gave us a positive feedback and show us interest in further work together. The key outcome of this collaboration is a planned publication, which was initiated by these experts who saw the value and the potential of our work to be spread to the public. And even though our main focus of the project was the Asian hornets, we believe that our solution could be adapted to other invasive species too. Since the Asian hornets is just a small piece of a puzzle. And finally, we invite you to explore our project and our analysis for yourself. You can easily scan our QR code and take a look for yourself, and even share it further. It's really a huge ecological issue that we think needs collective attention for the bees and for the future of all of us.
Thank you for a great presentation. Now, you will be officers, European Union officers, national officers, local government officers, just officers. Thank you.
Thank you for the presentation. My question is, is the movement of the predator the only factor you consider? Because there was the nice map where we can see the numbers, how they're changing, and the only factor you are looking at is the predator or something else?
So, thank you for your question. When we talking about our forecasting, we have basically 3 different models. Then we afterwards combine in one big. And when we talking about last ones that we showed here, we combined hornets spreading through Europe, plus historical changes of bee population, and plus how predators of hornets impact on hornets themselves. So it's combined view, but we taking only Asian hornets as invasive species. We don't take in like any other invasive species that could kill bees. We only talking about Asian hornets.
Okay, and did you analyze also some condition for this predator? Sorry, it's hard for me to say these speeches. What's like the what's the reason why is he spreading? If there's some reason behind it?
Yeah, it's not actually only reason, but the main thing why it's only currently start living in Europe and like felt comfortable to live there here because we have climate changing, and currently they're comfortable enough to live in Europe, and previously it was like really cold for them here, and problem with climate change that even like 1 degree Celsius can change the ecosystem. And they started spreading south of France, Spain, Portugal, but now they can go like further to Denmark because it's warm enough for them.
Okay, so and did you consider also put this factor to that analysis, to that prediction?
Yeah, we filtered all of the countries that have climate that is not comfortable for them.
Okay.
So you've mentioned, I loved how you pointed out where you can actually apply this. So that was lovely. And then you also mentioned that you can like ideally transfer this to new areas of focus so that you can also apply this to new animals or like other issues. So I was thinking, to what extent does this solution already scale, and to what like only your like expertise scales? You know, how much of this is reusable for you?
Thank you for your question. So for when we're talking about scaling these models, one thing that we need to have some data on this species, like historical data, so we can do our correlations, but it could be for any invasive species in Europe region specifically, and it could be extended even further in the world, but we are comfortable with working in region.
Okay, I got a follow-up question on this one. So it can be extended for plants and other, well, not only animals, but for plants, since you got invasive plants coming from Asia as well, right?
Yeah.
Based on, if you get the data, you can apply it for whatever species.
So our partner Gaia, that provided us with the main data source of observation data, historical observation data, they have main 2 tables. Like first one is observations, And second one was the relationship between species. And it includes different types of trees, crops, etc. So we're not only talking about animals, yeah, or any parasites or something like that. With parasites, it's a little bit more complicated on a biological side of forecast because they could be spreading like a little bit differently, but yeah, it could be done.
Okay, great. Thanks.
Probably the last question is because what if we like to start with some specific country? Could we have also like a detailed view of, for example, Spain or Denmark, on which part of the country is the most problematic?
We have mapping of spreading of hornets by each hive. So it's really detailed view. When we're talking about like historical data, and it could be applied on forecast also. The thing is, for forecasting approach, we used basically grouping them by country to have some weighting with additional academic researches and data. So that was the reason why we're showing it only by country. But we have data about like specific region. If we would have some request from like specific country, we could be like doing even more further detailed view on the problem.
Okay, thank you.
Thank you very much.